Hi, my name is Strik, and I am a research fellow at the Melbourne Brain Centre Imaging Unit in Melbourne, Australia. I would like to present our paper investigating axonal loss in major motor tracts in the brain in MS patients with no to minimal disability. So a quick introduction about MS. MS is a progressive neurological disorder of the central nervous system, so that's the brain and the spinal cord. It is associated with inflammation of the myelin sheaths around the axons, what leads to demyelination, but also axonal injury and axonal loss. So these pathological processes can lead to a wide variety of symptoms, of which motor impairments are very common and have a considerable impact on the quality of life. So how can we measure the structural damage in the central nervous system leading to these motor disabilities? We can use diffusion sensor imaging, which has been often used in the previous literature. However, with this method, it assumes that there's only one single fiber population, but many voxels contain partial volume fraction of two or more fiber populations, and up to 90% of the white matter voxels in the brain contain crossing fibers. So to overcome these issues, you could use a higher order diffusion model, such as constrained spherical deconvolution. So with this method, we can estimate the fiber orientation distribution within a voxel. So from the fiber orientation distribution, we can derive fiber-specific measures, also called pixels. Pixel is a fiber population within a voxel. And we can estimate the fiber density, fiber cross-section, or a combination between both. So besides the potential axonal damage in the brain, we were also interested in how axonal loss would relate to motor performance. So to measure low limb functioning, we used advanced laboratory 3D video tracking gait assessments. And to get a more precise estimation of upper limb functioning, we used the fMRI task, which was also part of our imaging protocol. So from this task, we calculate two measures of sensorimotor performance, the lag and the force error, so the delay and how accurate someone was performing the task. So the aim of this study was to compare the degree of axonal degeneration of these major motor tracts in the brain to motor performance using these novel axonal markers. So we included 28 MS patients with no to minimal disability, so everyone was able to walk without any aid or assistance. 17 healthy participants, and we used ultra-high field, a whole body magneton 70 Siemens system with a multiplet of 2, graph of 3, a resolution almost reaching anatomical imaging 1.24 isotropic, multiple B shells, 103 directions, and all within quite reasonable scan times. So we used the whole brain tractogram to select the cortical spinal tract using seed regions either in the primary motor cortex and the somatosensory cortex, as well as in the midbrain. And several regions were manually drawn to exclude tracts entering either the corpus callosum, cerebellum, and thalamus, and tracts terminating anterior posterior of the tracts. Similar to the cortical spinal tract, we use several inclusion-exclusion regions to select the intra-hemispheric tracts, so the tracts running between the hemispheres via the corpus callosum, and the cerebellothalamic tract, so running from the cerebellum via the red nucleus to the thalamus. So in these patients in the early stage of MS with known to minimal disability, we observed significant axonal damage seen as loss of fiber cross-section and fiber density cross-section throughout the entire tract. Interestingly, there was minimal overlap with the lesion probability map. So substantial axonal loss still occurred within the brain despite the relative absence of primary lesion pathology. When we looked at the inter-hemispheric tracts and the tracts running from the cerebellum to the thalamus, we observed similar results. Again, significant loss of fiber cross-section and fiber density cross-section, and again, minimal overlap with lesion pathology. And when we looked at the relation to motor behavior, we found that in MS patients, worse visual motor hand control was associated with greater axonal damage. And when we looked at gait patterns, we found associations between axonal damage and a shorter stance and smaller step width, as well as longer double support times. So to conclude, minimally disabled MS patients displayed a widespread axonal loss throughout the major motor tracts in the brain. Axonal loss was associated with subtle impairments in upper limb function and walking, and potentially axonal fiber analysis at ultra-high field could provide useful markers for emerging sensory motor network dysfunction in early disease stages. Thank you so much for listening.